Okay, so we should be on page 5. Today and tomorrow we're going to talk about the basics of hypothesis tests, and then on Monday we will actually start constructing them, or start conducting them. So this is the example that is on page 5. A recent study on the relative age effect and career success, evidence from corporate CEOs, suggests that people born in June and July are underrepresented in the population of corporate CEOs. This is consistent with the relative age effect, due to school admissions grouping together children with age differences up to 1 year, with children born in June and July disadvantaged throughout the life by being younger than their classmates born in other months. In their sample of 375 corporate CEOs, only 45, which is 12%, were born in June and July. Is this convincing evidence that the true proportion P of all corporate CEOs born in June and July is smaller than 2 out of 12? Okay, so we are interested in the true proportion of all corporate CEOs that are born in June and July. So what is our evidence that people born in June and July are actually underrepresented in corporate CEOs? We took a sample, and out of those 375 people, only 45 of them were born in June and July. That is less than 2 out of 12. Okay, why could it be that when we took a sample proportion, it ended up being less than 2 out of 12? Jackie?
Sample variation.
Sample variability. So one explanation is that people who are born in June and July are not at a disadvantage. So there is no disadvantage. We had a sample proportion less than 2 out of 12 due to sampling variability. So P really is 2 out of 12. So it really is true that 2 out of 12 corporate CEOs are born in June and July, but when we took a sample of all the corporate CEOs, we just happened to get a sample proportion that was less than 2 out of 12. What is the other explanation as to why we got a sample proportion less than 2 out of 12? Victoria?
The actual population proportion is less than 2 out of 12.
Right. People born in June and July really are at a disadvantage. So June and July kids really are at a disadvantage. Okay, how would I know for sure which one of those is the case? How do I know if P is less than 2 out of 12 or equal to 2 out of 12? Find P. Right, sample all of the corporate CEOs. Not logical though. So we're going to talk about how to figure this out. So how do we determine which of the two explanations is more plausible? We are going to determine how likely it is to get this sample proportion, or a sample proportion this small, by chance alone, assuming that there's no disadvantage. So we're going to assume that there's no disadvantage, and then figure out how likely or unlikely is it to get the sample proportion that we got. There's 3 ways to determine how likely something is. When I say how likely, what am I talking about? A probability. So I'm asking us to calculate a probability. What is one way that we could calculate a probability? Calculate any probability. This comes from first semester. What?
Wait, I was going to say something else. Never mind.
What did we do first semester if we wanted to estimate a probability that we didn't actually know how to calculate? Nothing. That's going to come up later, yes. Starts with an S. What?
Simple sign of sample.
No, thank you though.
Standard deviation.
No, thank you though. I guess yes, that has to be the a correct answer. A simulation?
Oh, yeah. Thank you.
Do you all remember doing this at the end of first semester where we would take a sample proportion and we wanted to know how unlikely it was, and so we simulated like 100 different samples coming from a different population or from a population, and we found where our sample proportion was? It was in a dot plot, like those 5-part questions. We could do that. We're not going to do that now. We could actually calculate the probability. Okay. We want to know the probability of getting a sample proportion. What symbol is that? P hat. This small, what's the symbol going to be here? The number is going to be 45 out of 375. What's the symbol going to be though? Less than or equal to. Okay. Ariana, this is where your normal distribution comes in. So this is going to be a z-score. So we have 45 out of 375, subtract something all over something. What is the mean? Or what's expected to be true? 2 out of 12. Standard deviation.
The square root of p hat times 1 minus p hat over.
Very good. Oh, you guys are lucky she came through for you. In this case, we're going to use p because we actually have our assumed value of p. So it's going to be the square root of 2 out of 12, 1 minus 2 out of 12, all over our sample size, which is 375. Please tell me that looks familiar. Okay. I'm going to tell you I already did this for you. It ends up being 0.0077, that probability. Okay, if this is our probability, do we think that kids born in June and July really are at a disadvantage?
Yeah.
Katie, why are they at a disadvantage?
If it's less than 0.05, it's not
Then it is statistically significant. So this is the probability of getting the sample proportion we got if 2 out of 12 were true. Because this is so rare, this is probably not true. Our initial assumption is probably wrong. Third way. Is there a way for us to take a sample proportion that we got and have an estimate of what the population proportion would be?
We're not doing a confidence interval.
Confidence interval. We're not actually going to do it, but you could. I will tell you, this is what the entire chapter is based on. Now, of course, it's not going to be that short. It's going to be a 4-step process again. You're going to have to state what you're doing. You're going to have to check your assumptions. That's what every problem is the rest of the semester. So,
You're gonna get like calluses.
you guys will be fine. Okay, so now we're going to jump into the stuff that you guys read last night. What is the difference between a null and an alternative hypothesis? The null is what is assumed to be true. It is a statement of equality. So it's always an equal sign. The alternative is what we look for evidence for. It's going to be a statement of inequality, so greater than, less than, not equal to, one of those. What notation is used? This is always in terms of population parameters. So you guys remember the idea with a confidence interval is you want to know something about the population that you don't, so you construct a confidence interval to estimate it. That's the same kind of terms that you would conduct a hypothesis test under. You want to know something about the population. You don't actually know the true population parameter, so you carry out a hypothesis test. So for the above example, okay, population parameter in this case is proportion. We're already told that P is the true proportion of all corporate CEOs born in June and July. So for our null, we are assuming that P equals what? 2 out of 12. We are looking for evidence that P is what? Less than, greater than, not equal to? Less than. These two numbers should always be the same. So that 45 out of 375, that's not going to come in handy until later. So we're not going to use that until later. Now, in words, what do these mean? So if P is less than 2 out of 12, what does that mean in words? In terms of corporate CEOs. Victoria?
There are like less CEOs born in June and July than expected.
Yeah.
Like they're at a disadvantage.
Yes. Yeah, so I'm going to say June and July kids are at a disadvantage. So then our null is that June and July kids are not at a disadvantage. So the next question, what are the most common mistakes that students make? They use sample statistics. So they would use p hat or x bar. That's not what I want. Sometimes students only give the null hypothesis or only give the alternative. They don't give both. You always need to give both. A lot of times they don't explain in words. So I always want the null and the alternative symbolically and then also in words. Okay, do you all think that you can do one? Or do you want to go through one more defining the null and the alternative before you try one? You can do one? No, we want to go through one together? Okay, we'll do one together and then you guys have one to do. So this is the top of page 6. The survey of study habits and attitudes is a psychological test that measures students' attitudes towards school and study habits. Scores range from 0 to 200. The mean score for U.S. college students is about 115. A teacher suspects that older students have better attitudes towards school. She gives the SSHA to a simple random sample of 45 of the over 1,000 students at her college who are at least 30 years of age. Okay, so a few things we need to determine. Who is she sampling? Jackie? Students over the age of 30. And what does she care about for each of those students? Their test score. And then what is she going to do with all of those test scores? She's going to compare them. She's going to calculate the mean. So mu in this case is the population mean SSHA score for all students who are at least 30 at this college. Right? She only sampled students at this college, so that's the only ones that she can really make a conclusion about. She wants to make a conclusion about all the students, but she only samples 45. So our null is that mu equals what value? 115. I'm not going to do this in words because I don't have enough room. Alternative is mu is what? Greater than. Okay, what does the alternative mean in words? Why do we care about it? Jackie?
Would be
this is the case, then students that are over 30 or at least 30 do have higher scores on average than college-age students. This case, the students who are at least 30 do not have higher scores on average than college-age students. Make sense? Okay, do the next one, please. Okay, I'm sorry if I didn't give you enough time, but here we go. Sigma is the population standard deviation of the distances traveled by the balls that are hit with the new 7-iron. So the null is that the standard deviation is still 15. Alternative is that the standard deviation is less than 15. So the distances have gotten more consistent. How'd that go? Okay, do we have a question as to why I chose less than? No, you all are just going to stare at me? Okay. Cool. Are you telling me?
Yeah.
Yes. Yeah, we want to see if the distances have gotten more consistent. If they're more consistent, there's less variability. Okay, when you carry out a hypothesis test, there are one-sided and two-sided alternatives. One-sided, you're going to see words like more than or less than. So greater than or less than, those are one-sided tests. Two-sided tests, so that's going to be a not equal to. You're going to look for words like changed or different than. So is there evidence that the distances, the standard deviation of the distances has changed? That would be not equal to. Big question, how do you decide which one to use? It's going to be based on the wording of the question. Your hypotheses must always be formed before you collect data. So you are never going to collect data, see which way it goes, and then form hypotheses. You're going to figure out what your question is that you're interested in, then you write your hypotheses, and then collect data. Okay, do you guys remember when we carried out confidence intervals, how you always had to write two interpretations at the end? You had to interpret the interval, and then you had to interpret the confidence level. For a hypothesis test, that's going to be the same. You are going to have two interpretations again. One, you are going to interpret the result of the test, and then the other one is that you are going to interpret what's called the p-value. Previous example that we did, this one right here, this is the p-value. So we should kind of be able to figure out right now what this is. This is the probability of the sample we got, or smaller, if the null were true. So we're going to write that out in words, and then we're going to do it for an example. So what is a p-value? A p-value is the probability of getting our evidence. So our evidence in this case is a sample statistic. Or stronger. Stronger meaning more extreme. Assuming that the null hypothesis is true. And of course, all of this has to be done in context. So we are going to do one together of interpreting the p-value, and then you guys are going to interpret a p-value. In the CEO example, so the one on the previous page, the p-value is 0.008. So that's what I calculated. Interpret this value. So you're going to say the probability of obtaining a sample proportion of 45 out of 375, or which way? So which way do we calculate our probability? 45 out of 375, or bigger or smaller? Smaller. Assuming that the birthdays of corporate CEOs are distributed evenly throughout the year. So assuming that P is 2 out of 12, that probability is 0.008. Probability of getting the sample proportion that we got, or smaller, assuming that there's no disadvantage. Okay, questions on writing the null or the alternative, or interpreting p-values before we go on? Okay, I want you to do this problem here with the person next to you, A, and then there's also a part B on page 7. So I'm going to give you guys 5 or 6 minutes. See how far you can get with that, please.
Okay. So what is the evidence that a new club is better? 13.9 is less than 15. What are the two explanations for this evidence? So one is that the new 7-iron allows them to hit more consistently.
They were closer together than one was 15 yards with more
Yeah, as a thesis,
Yeah, I was like, our evidence here is that this is less than that. And our evidence here is this is less than that.
The evidence that the new club is better is that after taking the sample hits when compared to the old 7-iron, standard deviation is smaller
Do we need a sentence for the where's the evidence that the new club is better? And it's just the 13.9 is less than more consistently. Okay, so then the other one is that the new 7 iron does not allow him to hit more consistently, and that it's just sampling variability.
Right. Which that.
I mean, we can just start off by telling what your tweet is that when we took a sample.
That's what it means. Yeah. Was less than. Yeah. Population standard deviation. Okay. So one we're kind of saying that it is better, and then one we're saying that it's not better.
Yeah, I think so. So those are the two explanations for
It's
the.
population standard deviation. This thing. And then this one is little axis.
Yeah, it was less than the.
Significance test using this sample data produced a p-value of 0.28. If the picture was being calculated and
Standard deviation
Or are we just saying
$80
like standard deviation?
You should write like.
of the old.
Like
Significant test taking example data produced a p-value of 0.28. Sketch a picture of what is being calculated and interpret the p-value in this context. Like a curve.
What is
The significance test.
Yeah, so it's, the new 7 iron is just
So the
better.
probability of obtaining a sample proportion or sample mean standard deviation of 3.9.
The old one.
So we can interpret it.
Yeah, I'm gonna interpret it first, right?
Yeah.
Because I don't know.
Yeah.
Is one of the variability?
Yeah.
What is this at?
So there's notice that it's not that tough for us, but we could say we're smaller. The new 7 iron isn't more consistent. He had, I mean, no, not SX is a symbol than whatever we have right now due to sampling variability. So the new 7 iron
In the middle is gonna go what you assume.
more consistent.
Has the same consistency as the old one.
And then you're gonna mark what you actually got.
We're assuming the new iron system has the same consistency.
SX
So, the probability.
So for this, is it?
You don't have it.
So is this one of the variability?
is less than 15.
Sample,
Sampling variability.
what you're assuming.
Well, last year, because it's your null state.
Context,
Oh, we're saying there is.
parameter,
So,
sampling.
for evidence that it's tested
Sketch a picture of what is the p-value in this. Wait, how does this say normal?
So I'm saying the probability of obtaining a sample standard deviation of 13.9 or smaller, assuming
Okay, you got about another minute.
13.9 or smaller, assuming that the new club does not make him more consistent. Yeah.
We're never even.
Oh, that's why.
Okay. part A. The evidence that the new club is better is that you actually got a sample standard deviation less than 15. Now, that could have happened for two reasons. One, the new club is more consistent, so it is true that the standard deviation of the distances traveled for that club is less than 15. Or the new club is not more consistent, the standard deviation actually is 15, but we just happen to get a sample standard deviation less than 15 because of variability. Is this ringing a bell from first semester now?
Yeah.
Kind of? Okay. Seems like the picture tripped us up.
Yeah.
I wasn't sure if you wanted like a picture of a guy playing golf. That was my first thought. And then I figured that wasn't what you wanted.
Oh, well, that was good.
Yeah.
Good reflection. This is what I was looking for. Okay. I've drawn many of them. Okay, 15 is what the assumed standard deviation is. We got a standard deviation of 13.9. The p-value is always the probability of that sample statistic or more extreme. More extreme just means further from the center. In this case, that would be less than. You don't know any other information, so you can't really label anything else. So then the p-value, interpreting that, the probability of obtaining a sample standard deviation of 13.9 yards or smaller, assuming that the new club is not more consistent, so assuming that sigma is 15, is 0.28.
What if we said the same consistency? Is that wrong?
Did you? No, it's not wrong. Did you put this in there, though?
Yeah.
Perfect. Okay, so based on this p-value, do we think that the new club is more consistent, yes or no?
Yeah, no.
No, it's not rare to get.
Okay, is it rare to get the sample standard deviation we got from a population where the standard deviation is 15?
No.
No. What's the rare cutoff? 0.05. Not very rare. So we don't have enough evidence that the new club is more consistent. Does that make sense? Okay. Can we talk about one other thing? We got to talk about it either today or tomorrow, so let's do it today. I want to do it today. Okay.
There's no option.
What are the two possible conclusions for a significance test? Do you guys remember that from your reading? Okay. We're going to talk about this in terms of if you're on trial or you're on a jury. If we're on a jury, what is the initial assumption for the person that is being tried? Go in and say that at jury duty and you might not have to do it. I'm kidding. Don't say that I said that. You're going to assume that the person is innocent. That's the initial assumption. What are you looking for evidence for? That they're guilty. Okay. Here is what's really important, is the conclusions that you make from this. If you find enough evidence for HA, what do you conclude about the person? That the person is guilty. Thinking in a court of law, if there's not enough evidence for HA, what decision is read?
Not guilty.
Not guilty. Is it ever said that the person is innocent?
No.
No. So this is really important. A conclusion is always in terms of HA. Either I believe HA or I don't have enough evidence for HA. Okay, if the person is guilty, we reject the null. So we found enough evidence for the alternative, so we reject the null. In this case, what do you think is true about the p-value?
Fail to reject.
Big or small? Small. You're going to have a very small p-value. If the person is not guilty, like Anna said, you are going to fail to reject the null. You're going to have a larger p-value. Again, generally the cutoff is 0.05. So last thing I want to do is write a conclusion for part B, the one that you all just did. Okay, here's how your conclusion is going to work. You're going to take that p-value and you're going to compare it to 0.05. Because we already said that that's kind of the rule of thumb. In this case, do I have overwhelming evidence to reject the null and believe the alternative?
No.
No. Okay, so we are going to fail to reject the null. It is incredibly important how you word this. You reject or fail to reject the null, but you are always going to word in terms of the alternative. So here's how I would word my conclusion. I fail to reject the null as there is insignificant evidence that the distances traveled by the balls hit by the new 7-iron are more consistent in other words, that the standard deviation is less than 15. Okay, so you fail to reject the null. All of this, though, is in terms of, hey, stop packing up. I have 6 minutes still. Do you see how all of this is in terms of the alternative? That there's not enough evidence for the alternative? Those are your options. If you reject the null, you found enough evidence for the alternative. If you fail to reject the null, you did not find enough evidence for the alternative. Always in terms of the alternative. In this case, do we have evidence for the alternative? The alternative is that sigma is less than 15. Do we have evidence for it? Yeah, our evidence was that we got a sample standard deviation less than 15. So we have some evidence, not enough though, to reject the null. Does that make sense?